Yeah, so welcome back to the part 2 of our introduction to the approach session. In part 1, you have seen in almost 1 hour, we were able to, write code across multiple languages. We could understand code which was generated by AI, which was generated by ChatGPT. We could understand the code, but of course, at very basic level. But in 1 hour, we were able to do that across multiple languages. Fine. So that was the key factor. In depth of the same of syntax, we would be discussing in the course because that's for 15 hours and this was just for 1 hour. In 1 hour, if someone could reach a stage where they could understand across multiple languages, basic code, certainly 15 hours, they could also start writing and a lot of new things they would explore. And even the training goes on in a slightly different way. When it's elaborated, we also teach them a lot of intricacies, the fundamentals, how to build any code, how to start, how to keep moving. So the exposure would be a lot in detail. Now we will move on to object-oriented programming. Now that we understand memory statement, assignment operators, output statements, functions, methods, with this basic thing in mind, let's switch on to object-oriented programming. Fine. So what's object-oriented programming? Before that, we'll look into a couple of principles. Yep. What the principles are. Till now, we have learned about tokens, statements, and they are generated through syntax. Now we will learn how to use these statements in order to build a program. And what's needed in order to build a program? To build a program using statements, we have principles. If we understand these principles, then building programs is never a challenge across any programming language. Let's move ahead. Then let's learn something about programming elements. How many elements do we have in water? Yeah. How many elements do we have in water? 2 hydrogen and oxygen in 1 liter of water. What if we had 10 liters of water? Still the same. Similarly, programming has 2 fundamental elements. Yeah, we have 2 fundamental programming elements. One is data and other is instruction. How these two work with each other gives us various programming paradigms or programming principles or programming methodologies. And these are, yeah, like you can see, when you have 10 plus 15, 10 plus 25, data is 10 and 25, instruction is your plus. 10 greater than 25, 10, 25 is your data, greater than, lesser than, whatever comparison you do. Yeah, that's the instruction. Print hello all is the data and print is the instruction what we are giving. So any statement, anything in programs when we write, it comprises of 2 elements. One is data and other is instructions. Integer num, integer is data. Request for memory space is the instruction. Now, with this programming elements in mind, that's the data and instructions, let's discuss about programming elements. Yeah, there are 2 programming principles. Yeah, within our mind, the programming elements. Let's start discussing about programming principles. So 2 core programming principles we have: structured programming and object-oriented programming. So what is this structured and object-oriented programming principles? Anyways, we have the 2 elements. One is data and other is instructions. And then when it comes to structured programming, data is exposed and instructions are hidden. Whereas when it comes to object-oriented programming, the principle says data must be hidden and instructions must be exposed. With this in mind, let's try to explore object-oriented programming. Yeah, then object-oriented programming is not a language. It's a concept that consists of 4 features, which are encapsulation, that's binding of programming elements, data and instructions into a single unit. Then abstraction, levels of hiding the programming elements that are encapsulated. Then polymorphism, which gives the multiple behavior of data and instructions. Finally, inheritance, in which the programming elements of one encapsulation are used to build another encapsulation, and this again leads to encapsulation. So back to feature one. In that encapsulation, again apply abstraction, then polymorphism, then reuse them through inheritance. Inheritance results again in encapsulation. So this cyclic pattern goes on. And these four features comprise the object-oriented programming. Any programming language that can implement, that can exhibit these four features can be considered as an object-oriented programming language. Various examples: Smalltalk, C++, Java, Python, Ruby, Apex, Swift, Kotlin, Golang are multiple object-oriented programming languages we have. So these four features across various programming languages all exhibit these features. Like C++ has encapsulation, but only of one type, and that's achieved through keyword. Java, two types of encapsulations, and we have keywords for the same. So K indicates here keywords. Some languages exhibit one type of encapsulation, some other languages exhibit two forms of encapsulation, but either ways, it is implemented through keywords. The language supports it, right? Similarly, abstraction. C++ has 3 levels of hiding. Java has 4. Each language has its own capabilities of hiding and exposing the elements. And all this is again achieved through keywords. When it comes to polymorphism, it is exhibited through compiler. Yeah, the translator itself has this capability. And in some languages, it's a combination of the translator plus keywords. So some exhibit 1 form, 2 forms, 3 forms, different forms they exhibit. And when it comes to inheritance, again, in some languages, it is through operators. In some languages, it is through keywords. Some exhibit 3 in full-fledged. 4th is partially available or partially functioning. Yeah, this way, all the 4 object-oriented programming features can be exhibited through these languages, either using keywords or operators, or the translator supports it. This is how, object-oriented programming is exhibited across various languages. Now coming to how to implement it in a language. Yeah, it has to be implemented, isn't it? Just by having encapsulation, it doesn't help. It has to be built, and for that support is given. So what's encapsulation? As we discussed earlier, it is binding of programming elements into a single unit. Yep, you could see a capsule. It has the granules and the powder, everything into one single unit, isn't it? That's the key medicine. Yeah, and this encapsulation is achieved with keywords. Out of them, one keyword is class. We will restrict our discussion to class. We will not get into the second one because, as we said, we will focus only on the essentials in these 2 hours. Yeah. So class, what's a class? Blueprint of real world existence. Or it can be considered as collections of features and behaviors. Other way around, if we go back to the programming elements, data and instructions, class is a collection of data and instructions. And finally, it's a programmer-defined data type. Earlier, we have seen data type, numeric, string, Boolean. They were all system-defined. Now, this is programmer-defined data type. Every class is a programmer-defined data type. Yeah, example like shirt, mobile, laptop, hundreds of examples, right? Anything that you see in this world that you recognize is a class, basically. Yeah, you see a laptop, that's a class. Your mobile, your shirt, what you see there on the screen, everything is a class. Yeah, now next. Discussing more about class. Yeah, class is a blueprint. What does blueprint mean? Blueprint is something, which tells about the features and behaviors. Like, for example, I have a free space of 2,400 square feet. Fine. Then what do I do in this? 15 square feet by 10 square feet, I'll have a bedroom. 18 square feet by 14 square feet, I have a kitchen. So this 10 by 15, 18 by 4, these are all my data. Bedroom, kitchen, this is the instruction what I'm giving there. Yeah, this is how it works. So it's a blueprint. I can't live in it, but if I go to the architect, he gives me this. Oh, so real world, when I build, this is how it's going to be. This is how my 2400 SFT is going to be utilized. So it's a blueprint. It tells if this were to be in real world, how would it look like? But as of now, it describes only features and behaviors, or it's data and instructions. Everything means the same. Blueprint of real world, collections of features and behaviors, collection of data and instructions, one and all the same. Whatever we are considering as features is actually data. Whatever we are saying as instructions is the behavior. So they're all the same. They all mean the same. And the fourth definition of class, what we have seen, yeah. So that's, what is going to be a programmer defined data type. Yeah. But one basic thing to understand, how do we know what a class is? Yeah. Any class, we recognize it by its features and behaviors, isn't it? How do human beings recognize? You give me 3 black color boxes. Yep. One, I will recognize it. Oh, this is a mobile phone. Sorry. Second, I recognize this is a projector remote. And third, I can recognize it. It's a television remote. Oh, one second. Yeah. Sorry. So this is how human beings recognize now. Mobile, my AC remote, and my television remote are all 3 are in black. But what features do they have and how do they behave? That's important. AC also has a plus and a minus button. My television remote also has a plus and a minus button, but don't behave in the same way. They don't behave in the same way, isn't it? On my AC remote, when I press plus button, it increases the temperature. And when I press the minus button, it decreases the temperature. One second. Yeah. Now, when I take the same plus button on my television remote and press that, it might add on to the volume or it might change the channel. Similarly, minus might reduce the volume or change the channel. So now, even though the colors are same, what text is seen on them is same, but the behaviors are not the same. So human beings recognize anything in this world based on features and behaviors. Hence, we call that as a blueprint. Yep. Then coming to the fourth definition, it's a programmer defined data type. Example, shirt. Now you can see a shirt with one single value. Can I represent a shirt? Not possible, isn't it? A shirt has a pattern. It might have reviews. It has a price. It has a size. It has a color. It has a kind of fit. Multiple things are there. Can I represent it with one single data type? No, not possible. The pattern is different data type. Price is of different data type. The fitting is of a different data type. All features are completely different. Each feature is of a different data type. Then how could I have a single value to represent shirt? It is not possible. Hence, I have to create a new data type in order to represent a shirt. And then I mark this shirt as a class associated with some features and some behaviors. Features of the shirt could be its pattern, the brand which it belongs to, the color, the fitting, the size, all these, the kind of button it has, the kind of material fabric with which it's made out of. All these become the features, whereas behaviors, I can wash it, I can iron it, yeah, I can dust with it, I can tear it. All these will become the behaviors of the shirt. So this way, a new data type comes into existence and we consider that as a class. So class by itself creates a new data type which will have its features and behaviors. So it can be treated as a complex data type. And then similarly, you can take a mobile, you can take a laptop, all more or less same, you can define them. Yeah. All object-oriented programming languages. Yeah, in all object-oriented programming languages, how do we identify a class? A class is something which we recognize in this world, or something which we can imagine to exist, like the superheroes. They don't exist in the world, but that's how we imagine them to be. So that's also a class. What you see and recognize in this world is also a class. So book, pen, classroom, table, chair, student, teacher, anything that you recognize, anything about which you can imagine becomes a class. Now, how to represent it on the system? How to write it? Back to syntax. Everything comes with syntax. So how do I build it? Class, class name, then its delimiters, demarkers. Where does it start and where does it end? So class, class name. And class name is going to be the new data type which we are going to create. And class is a keyword. Yeah, class is a keyword. Class name is an identifier which we will use. But hereafter, that class name is going to become a new data type. So now let's make use of ChatGPT and our Excel sheet to understand the implementation of class across multiple languages. Yeah, let's get into our Excel sheet. Let's move on. Okay. So how do I define class? Syntax of class in various programming languages. Yeah, how does it appear? C++, class, class name. Java, class, class name with its delimiter. C#, class, class name. Swift, class, class name. Kotlin, same. Python, class, class name with colon. There it marks the beginning of it. Ruby, class, class name. JavaScript, same. Golang, type, class name, struct. Scala, class, class name. Solidity, directly class name, no keyword class. So this is how you can see across multiple programming languages, you have this syntax of class. Let's go to ChatGPT and ask, can you create an empty class in Java? I want an empty class. I don't want to have much features inside it. Yeah, let me copy the code. Let me put it back. Let me put it back into the document. Let me paste it here. We are beginning object-oriented programming here. And this is code in Java. Let me paste it. Public class, class name. Yeah, it's an empty class. That's all. Why public? We'll discuss in our abstraction level. But what we learned perfectly works here. Same way, I want to do the same thing here. Instead of Java, I will use Kotlin. Save and submit. Yep. You still get the same code. Now it's Kotlin class, class name, empty class, because we said you write an empty class, so it writes an empty class. Similarly, let me change that from Kotlin. Let me move on to Swift. Again, see the same, copy the code, bring it back. This time it's Swift class, class name. So if you understand that fundamental of writing, then it's same, because this is how translators are built. If you start learning programs, from a developer point of view, where how I start remembering programs and start writing, then we are actually entering into a dark dungeon. It's never going to help any person. Yep. By default, some people might learn coding, that's okay with them. But coding should be everyone's cup of tea. Everyone should be able to code. What's so hard in it? Yeah, and it's such a highly paid skill, and it's much easy, risk-free. Like if I say I want to learn it like a bike riding, fine. When you learn a bike, which bike? I can learn any bike and I can ride any bike. Then why isn't the same principle applicable to coding? When we are learning a bike, I don't learn the route from place X to place Y. I understand how to balance the vehicle, how to switch gears, how to keep the vehicle in motion, and how to move in the traffic, how to navigate in the traffic. This is bike riding for me, isn't it? This is how I learn. If those principles are considered in programming, then this is what we are doing. We are learning the principles of programming across any programming language. It's the same. Like how you build your statements using tokens, how you take the principles to construct programs, everywhere this is going to be same. If I learn these, I can switch from any language to any language. That's very important. Fine. So this is about the class. Let's move ahead. Yeah, let's continue our presentation. Now we are able to build a class across any programming language. Hardly a few minutes, right? Just few minutes. Yep, we have seen our Excel sheet. You could see Chat GPT. You can type it in Google Bard as well. It gives the same result. Absolutely no difference. Now, we said class is going to consist of, it's a collection of features and behaviors, isn't it? Data and instructions. Like people in a family are called members of a family. Players in a team are called members of a team. People in a club are known as members of the club. Same way, the data, the instructions, the features, the behaviors within the class are considered as members of the class. And what is the class going to consist of? Data or properties or members, data members, which are features, and behaviors are the instructions. Class is going to consist of these. Now, how to know what features to take, what data to have? Simple. Properties using which I identify the class in this world, or how I distinguish one class from the other, are the features. If I take a book, how do I know this is a book? Because it has some pages in it, because it has some title, because it is associated with some author, then I mark it as a textbook. Same thing, if it's a magazine, I know what the features of magazine are. I pick up a mobile, I know what features it has. Then those all become our data members, the instructions. Fine. So book, features, title, year of publication, author, edition. Pen, features will be brand, ink type, yeah, color of the pen, price. Student, features, name, grade, email, phone. Yep. How to include these features into your class? Because class is collection of these features. How do you add them? Go back to the syntax. Syntax of what? Memory statement. Class name. Now it's going to consist of data, which is features. Syntax is same, data type name, how many features you have, mark the features. This is back to the same syntax of your memory statement. Whichever language you're writing the class, that language has memory statement, write this syntax here. You will be marking the data members. You will be marking the features. You're in the game. That's all. Yep. So class book, features, syntax, data type name, title string, int, year of publication, string, author name, int, edition. So whatever data types are supported in the language, use them to write. Another example, yep, you can take of class student, features, syntax, data type, always same. So back to the syntax of memory statement. This was the reason why we created that part 1 for you all. Otherwise, if you directly come here, write this string title, again, like how did all this come? Understand, in our 15 hours approach, we will clearly explain. No token in the program is going to come by hook or fluke. It has a syntax, it has a principle. If we understand that, we can mark all the tokens of the program. You don't have to remember any line, any statement of your code. everything that comes in your program is going to come based on syntax and principles. Once you understand and start practicing this way, you are bound to become an awesome programmer. No one in this world can stop you from becoming that. That's the key behind it. And rest, the more and more you practice, you keep evolving as an experienced thing. 15 hours is to create that gateway to you so that you enter into this coding world. It's not an end by itself, but it'll give you that freedom. It'll give you the capabilities to work across any programming language. This is what happens. Yeah. So now, after the features, what else is class is going to consist? After data, what else it is going to consist? It is going to have instructions. How do we bring instructions? We said these are behaviors. How to bring the behaviors? These are functions or methods. The way how we have written functions, methods earlier, we are going to mark them here. The same syntax we are going to use here. Yep. So class name, instructions. I'm not elaborating on instructions here. I'll be focusing on behaviors. Yeah. We will be focusing more on instructions part, not the features part. I'm not going to touch features because already it is there. So in benefit of time, yeah, whatever we have, I would like to focus only on instruction part. So how do we write method in a language? Return type, method name, list and sequence of input declarations separated by commas, enclosed, header part is done. Followed by that, we have the body that consists of statements to perform well-defined tasks. Now, how many you can have? Immaterial. Have as many as you want. The count doesn't matter. 10, 20, 100, 500, 1,000 depends on how complex thing you're going to build. Yep. So no restriction at all. Build as many as you want. But the key factor here is when you put all this together, like class will have two programming elements, data and instructions. How do you mark data? Features. Instructions are behaviors. What's the syntax? Data type name for your data. And what is the syntax for instructions? Same as functions, return type, method name, list and sequence of input declarations separated by commas, enclosed in parentheses. Then the body comes with the statements to perform well-defined task. Yeah. This is the syntax of writing a class, irrespective of which language you're working with. Yeah, this is the same across all languages. Now, even though the count is immaterial, but the categories of methods we have in a class, we put them into 4 distinct types. Some methods are classified into create or initialize member methods. Some fit into input member methods, process or action member methods, and the last category is output member methods. We classify them into these 4. Why these 4? Member methods or functions or instructions, they are not just going to come like that in our class. There is a principle. Yeah, there's a principle for these member methods. Every member method must provide service to the data members. Every member method must provide service. So what services? Create or initialize service, input service, processing service, or the output service. Definitely they will be providing either of the 4 services. Accordingly, we write the methods. So count can be numerous, but categories are 4. This is how we enter. This is where we write. So you can just look into the syntax of what we do. So this is according to the principle. Methods are there, but those methods, the body, what we do, every method performs well-defined tasks. So the body which comes according to the service, what it creates, and including this return type, data type names, inputs, they don't come by hook or fluke. Remember, every token, we will bring them only based on syntax and principles. How to know the return types, how to know how many inputs to give. There are principles for all these. We will be working with them in detail, irrespective of which language it is. Once that idea comes, you will be not only, seeing code, you will understand what the code does as well. Oh, why this class is defined? Okay, these data members, these member methods, fine, this is what each member method does, irrespective which language it is. Yeah, that's why this program, this course is very essential for every developer. Yeah. Then input methods, what will they do? Load values. Yeah, their job is to load values. What will output methods do? Their job is to display. So just an example for student, if I write, yeah, student has student name and age, then we will write an input method. What will that input method do? Void set values. It takes two inputs because it has to load two values. Yeah. Then the body, the parameter will be loaded into the data member student name, and the second parameter value will be loaded into student age. Fine. So two values are there. This is an input method. It loads values into the data members, loads values into the features. And similarly, output method displays values of the data members. Yeah. So this example is in C++. Any language you can use, just an explanation of it. So this is displaying the values of data members. This is how it works. Yep. So OOP stands for object-oriented programming. It's not a language. It's a set of 4 features. Fine. Then class is blueprint of the real world. And the key factor here, it makes machines to think like humans. On one side, humans are trying to think like machine. On the other side, we are making machines to think like humans. So class is crucial for that. Then most important part, where in all this is the object. Yeah, we have to get the object because class is only a blueprint. Then object is the real world existence of a class. You, me, all of us are real world existences for a class called human. All of us are instances of a class called human, or we are variable of type human data type. Human is a data type, then all of us are variables of human types. Yeah, we all are instances of a human class. All of us are objects of a class called human. God is the blueprint. When someone helps us, we consider them as God. So they are instance of the class God. You feel God has got features and behaviors. Oh, very helpful person, very compassionate person. And when you see these features and behaviors in someone who comes to rescue you, you see these features and behaviors in someone, you make them an instance of God. So this is what happens. Yeah, so this is what object is. Now, how do we bring objects into the code? Objects have to be created. To create them, we have syntax. Syntax is again similar to memory statement, data type name. But now data type, class name becomes the data type. And what name you give becomes your object name. Along with that, for dynamic memory allocation, we use new along with class name. Yeah. So we have two models in creating classes, in creating objects. One is static memory and the other is dynamic memory. Data type name is static memory creating object. When you have class name, object name, load with new class name, that's a constructor, then this is a dynamic memory allocation way of creating objects. In some languages, objects are created through static, whereas in most of the languages, objects are created with dynamic memory allocation. All this, what is static dynamic memory allocation in detail, we will be discussing in our 15-hour approach. Yeah. So syntax, you create the object to static memory, you can create it with dynamic memory allocation. Both options are there. Yeah. Some languages support one, most of them support the other. So our class name is the programmer defined data type. Object name is name identifier, what we use, new, and that class name with parenthesis is constructor, initializer. Different names are given in different languages, but their purpose is fixed. Yeah, so we will be discussing about them also in detail in our program. By now, how does method work, or Who calls the methods in object-oriented programming? It is the object which calls it. How to call it? We have the dot operator which does that, and with the object dot method, then it invokes the method, and method will provide service to the data members of the invoking object. So syntax, class name, object. Now one is static and other is dynamic memory allocation. We are showing to in both the models. Now object dot set values, current 28, 30,000. Employee one dot show values. Similarly, employee two, yeah, set values. We are passing some values, and emp2 dot function method. How do they work? Let's see from memory point of view. Class employee, it has its data members, string emp name, int age, double employee salary. It has methods. Create method we have not defined. Input method we are defining for that class. Output method also we will define. Action we will not define in our full-fledged program. We will work with all these. Input job is to load values into data members. Output job is to display the value of data members. Naming convention also we will refine in the course. Yeah. Now inside of object creation, emp1 is created. Yeah, with the 4 methods surrounding the data members. Yeah, employee name. So it is loaded with current 2930. This is what that set values has done. Same way, when it comes to employee 2, it is also surrounded by its own member methods, and they work with its own data members. It has its own data members to work with. emp dot show values will go to emp1. In emp1, it comes to show values. This emp1 show values can access only current 29 and 30,000, which are the values in this data members. Similarly, emp2 dot show values are going to work only with the data members inside emp2. Show values of emp2 doesn't even know that there is emp1 existing. It has got nothing to do. That is why this is object-oriented programming. Every object has an existence for itself. It serves its own purpose. So that's the concept of object-oriented programming. And in detail, we will be discussing more in the course. Yeah, this is just an overview, an idea to help you understand how we are building object-oriented programs. Yep, we will go to our ChatGPT and check this out as well. Yeah, let's go to ChatGPT and check out object-oriented programs in different languages. Let's say create a class, sorry, let's spell it properly. Create a class employee in Java. I haven't taught you Java. I haven't taught you C++. I haven't taught you Python. But now see, create a class employee in Java. Let's move. Let me take this code, copy it into a document. This is a Java code. Let's see. I hope you will understand this code now. This all starts from where? Class, class name, fields, string, first name, last name, employee ID, salary. These are the features. Now, we said methods are classified into 4 categories. This constructor is for your create. We didn't discuss, no problem. Now, get first name, get is for output, set is for input. So it is loading first name, it is displaying first name, it is returning first name. Same way, it is loading last name and returning last name. It is loading employee ID, returning input, output working together. And then you can see salary part also working. Fine. And then it is also doing some logical task. We said this is going to work in a very, actions are also there, isn't it? So some employee name conversions are being done. And now you can see here, class name, object name, load with new class name. Of course, some values are being passed. We will discuss them in detail. So I didn't discuss anything about Java in the past 40-45 minutes, but you're able to understand what's basically happening here. What is this? This also we will discuss. Yep, that is pretty clear. Yeah. And let me rewrite the same thing. If that part last little bit confusing, Java with default construct. I'll just put in default constructor there in order to, just not have that values in your object. It looks quite empty. That's all, rather than having all the values. Yeah. So let me copy this and paste this here. Yeah. Everything looks same. Now towards the end, you see this, what we have done. The same what we have written there. We didn't learn Java, but still we understand what's happening here. Same way, I'll change the same program. We have discussed nothing about Python. So I'm going to use Python here. Save, run it. Whatever comes, let it come. We'll pick that code, copy. This is Python code, save it. Class Python. Yeah, create method, initialize. You're having name, salary, only few members, print name, print salary. Yep, you're printing. You're creating employee. Because there is no concept of writing data type name, isn't it? In Python, we just write name, data type picks up, and directly you write your constructor here, which is your class name. This is your class name. That's it. So Python, you're able to grasp. Same way, change this. Yeah, I'll remove that default constructor, everything. Doesn't matter whether it gives something else also. Let's just put Swift, create employee class in Swift. Some people might not have heard this name called Swift, but still no problem. You don't have to know the language name to understand the language. Yeah, check out class employee. Yes, okay, 1 second. That went somewhere in between. Yeah. Hope it did copy it. I'll copy this code. Sorry, I didn't copy it. Now you see Swift class employee var name data type. Var name data type, memory statement syntax. Followed by that, you have your method syntax, function name, body to perform the task. This is display. It will display information. And here, init, initialize, create is there to initialize values into data members. So it is loading values into data members, displaying value from data members. Now you can see employee, load with employee. You can see the constructor coming into the picture and loading values into it. So quite simple. Again, object dot method name, it displays the values. Object dot method name. So everywhere, any programming language. I didn't teach you any programming language. I just gave you some concepts and principles. And if you're applying them across multiple languages, it seems like it is working. Everywhere it works. Absolutely no problem. Get back to your Excel sheet. How to write class. Data member is syntax of your memory statement. How do you write your member methods? Yeah, the syntax of it. Put them into the class. How your class is defined with collection of data and instructions. We know what they are. Now, how to create object. You have the syntax to create object across multiple languages. Use the syntax to create objects. And how do you call your methods post that? It is all languages same, object dot method with suitable inputs. Job over. So hardly in 1 hour, you are able to understand the concepts across multiple languages. Yes, in the same way, how we identified code using the same in the future, like in our 15 hours program, you will also learn the principles of developing all these kinds of applications: media player, video streaming applications, net banking applications, ATM machines, swipe machines, payment wallets like Paytm, GPay, PhonePe, e-commerce applications like Flipkart, Amazon, Myntra, image processing applications, social media applications, gaming applications, music streaming applications, healthcare, fitness applications, document editors, browsers like Chrome, Safari. These are all apps which are built, right? So we will be teaching you the principles of building these applications also. It is not like teaching you some 4 or 5 lines of code how to write. No, you will also understand the principles. Okay, I can even develop a project using the same thing. Yeah. So that is where you will end up in the 15 hours program. So many kind of apps: Truecaller, Just Dial app, 19 Acres app, Uber, Ola, Rapido, Link, Gmail, Yahoo Mail, Swiggy, Zomato, matrimony sites, our online meeting apps like Zoom, WebEx, GoToMeeting, Google Meet, Microsoft Teams. You name the kind of softwares, thousands of application skeleton systems we can discuss. Like how we discussed the programming language. I didn't teach you any language, but you were able to understand code in multiple languages. So with the help of our reference Excel sheets, with the help of the proper prompts, what needs to be done, and with the help of our mind maps, we also have proper mind maps to assist you. We also have games to assist you, video games. Yeah, your mobile app games. You play them, you start thinking like a developer. Mobile gaming applications are there. All these are existing to support you people so that you become a much better developer. Yeah. And these are the additional resources what we would be providing in the program to you. Yeah. The learning resources would be IDE. I'll just show you the IDE. Yeah. I've also shown it earlier. You can write all your object-oriented programs here. Like this is written by one of the student. Yeah, class book started writing. Hardly any time they start writing it. Fine. So we have an IDE where you can write code across multiple languages. Yeah. We also provide you mind maps so that you understand these concepts of coding, remember them and apply it in your real life and build projects from there. For everything, we have mind maps, worksheets to practice in the right way, documents for you to refer with, Excel sheet, which you have just seen. It's a master key for all languages. Fine. Mobile gaming app to practice, a learning management system, which will have the 15 hours video for you to access. Post registration of the course, you will be having access to the LMS, where, any point of time in your life, you can come back and refer to these concepts, listen to them, and again start applying. So whether you are a fresher or you're in middle of your engineering or final year of your engineering, or you have completed your education, looking forward to upgrade your skills, move from BPO to IT, non-IT to IT, you're a non-IT student trying to learn programming, you fit into any bracket, doesn't make any difference. Ours is a master key for coding. You will be able to understand, write code in any programming language. Fine. And along with this, we also have Copilot, yeah, ChatGPT, Google Bard, many other tools which will assist you in building programs. Fine. So like you can see here, yep, I'll just show you. Write employee class in Kotlin, or create an employee class in Kotlin. Right? Starts writing whichever language you are in. It makes no difference for it. Yeah. So this is where, okay, so this is into the JavaScript part. Yeah, good, simple. Of course, this came up in JavaScript in a different approach altogether, but that's okay. You see, this way a lot of code gets generated. This is in a different context altogether. Yep, I can go back here, remove this code completely. Here I can have write a class in Kotlin, right? An employee class in Kotlin, or create an employee class in Kotlin. Makes no difference. Done, it's ready. The class is ready for you in Kotlin. You can understand. Class consists of data members, member methods. So your class is now having string, name, integer age, integer salary. These are the three data members, and it is printing it through a function, function name, println is to display message plus value, message plus value. We have discussed it in part 1, how each language prints. Printing is only 3 patterns, only message, only value, or a combination of message and value. How do you put them together and get it done? So this is Copilot for you. Yeah, a lot of tools are coming up in the sphere of artificial intelligence, but if you interact with it, you understand what it is generating, you should be able to modify. So you and AI together play the major role. It's not you alone, it's not AI alone. That's why it's called Copilot. 2 people, working on that flight. You people are going to work on that flight. The flight is going to take off along with you. It's going to move along with you. It'll land finally with you guys. So that's why it is Copilot. AI cannot replace you. You cannot replace AI. Together, you will make a remarkable achievement in your career. So all these things are covered in our program. So this 15-step approach, our 15 hours, 15 programming language approach. You will be able to work across all programming languages. 15 is only on the minimum side. You bring any other programming languages, you will be able to work with them. We don't restrict it to 15. Go with any language. These concepts are applicable everywhere. Fine. So this is how we do it. So this was an introduction to our approach. This was an introduction to our approach. We invite you to take our 15 hours program, so that never again programming will be a challenge for you. And we appreciate the college management or the senior members of the college who are committed towards the progress of students for taking up such a program. This intro part is created especially for you people, so that you get a look and feel of our approach, how we are going to do it, and how our 15 hours will definitely save hundreds of hours of the students and management as well. And this would enable them in their placements. This would definitely create a better career for them. The way they look into programming definitely changes. It is in collaboration with the college what we want to, impart this technology to the students. AICTE has approved our training curriculum under NEET 3.0. So we really thank them for doing it and bringing it forward to the students. We thank the college management people and all the responsible people in the college who are willing to educate the students and add more value to their education. With that, we conclude our program. Thanks very much for giving the time, for sparing your time to watch this video. And looking forward for your feedback, your suggestions, and further discussions on the training with you. We thank you a lot, and thanks for your wonderful time. Take care, everyone.